Hello and good day. Welcome back to our class. This is teacher Onin Guzman, and our topic for today is linear inequalities in one variable. This is for Activity 3, Grade 7, Part 2. Alright, for our activity number 3, so we have solving linear inequality in one variable using, so step 1, we use the properties to solve each inequality. And number 2 is to write the solution set, graph, and check. Okay, so let's start. So let's have here first for addition and subtraction properties or SPI and API. So in number 1, we have x minus 7 is greater than, negative 8. So again, so what we're going to do is simply, add 7 on both sides of the inequality. So we have x is greater than negative 1. So if we will graph this on our number line, so this is x must be greater than negative 1. So let's have negative 2, negative 1, 0. Since the direction is moving to the right, so we will copy this one. Okay, but we will encircle negative 1, and we will move our okay graph to the right. Okay, there you have it. Put arrow. Okay, so if we will let, to check this one, so if we will let, or if x is equal to 0, so again, using the inequality x minus 7 is greater than negative 8, so we have 0 minus 7, is it greater than negative 8? So clearly, negative 7 is greater than negative 8. So this is true. Okay? Next, let's move on to number 2. So in number 2, we have x plus 10 is less than 18. Again, so we will subtract both sides of the equation by, or inequality by 10. So we have minus 10 here and minus 10 also here. So what we have is x is less than, 8. Again, on number line, so let's have here 6, 7, and 8. Since, we have less than 8, so let's exclude 8. Then, shade. This time, going to the left side. Okay. Okay, so this is our, graph of the inequality. Now, so if we will check, so if we will let, if we will, x is equal to 7. So from the inequality, x plus 10, is it less than 18? If we will substitute, x is equal to 7. So 7 plus 10 is less than 18. So we have 17 is less than 18. So we can see that 17 is less than 18. So this is our solution set. So by the way, we can write this one in interval form such that this is actually x such that x is less than 8 in interval notation. Okay? Next. So we have number 3. So we have x plus 3 is, less than or equal to 12. So again, we will subtract both sides by 3. So we have x is less than or equal to 12 minus 3 is equal to 9. On our number line, so it means less than or equal to, so it means we may include, actually 9. So we have, let's have 7, 8, and 9. So therefore, we can include 9. So shade this part, okay, and we will move to the left side. Okay. Now, if we want to check, let's check. Okay, let's choose. Okay, x is equal to 9. So if x is equal to 9, so from the inequality x plus 3 is less than or equal to 12, substituting the value of 9, so 9 plus 12, or 9 plus 3, okay, is less than equal to 12. So we can say that 12 is less than or equal to 12. By the way, in interval notation, we can write this one as x, such that x is less than or equal to 9. So that is for number 3. Let's move on to number 4. So this time we have, okay, decimal. So like what we have done in the previous example, we will apply addition property of inequality on both sides of the equation. So we will add 3.5 to both sides of inequality. So we have x is less than 6.5 plus 3.5 is equal to 10. Okay. So again, on the number line, let's have 8, 9, and 10. So we will exclude 10. And then the direction of our inequality is moving to the left side. Okay. All right. So we have now the graph of our inequality. Let's pick now 9. So if x is equal to 9, to check our inequality, so we have, okay, x minus 3.5, okay, is it less than 6.5 if we will substitute 9 to x? So 9 minus 3.5 is actually 5.5. So clearly, 5.5 is less than 6.5. So this is, okay, our solution. So in interval notation, we have x such that x is less than 10. Okay, so let's move on to problem number 5. Again, another decimal. So we have negative zero point 0.5. So what we're going to do is we will add zero point 0.5 to the both side of inequality. So we have zero point 0.5. It's zero point 0.5 here and plus zero point 0.5. Okay, so what we have is x is less than, okay, 0.9 plus 0.5 is equal to, okay, 1.4. Anyway, this is x is less than or equal to 1.4. Now on our number line, 1.4 is between 1 and 2. So we have here, say for instance, 0, 1, 2, and 3. So somewhat here, 1.4 is between in this side, on this part. So we shade that part. Then this is moving to the left side of inequality. Okay, so if we will let, for our number 5, if we will, example, I'll choose 1. So if x is equal to 1, so we have here x minus zero point 0.5, is it less than or equal to 0.9? So 1 minus zero point 0.5, is it less than or equal to 0.9? So we have zero point 0.5 is less than or equal to 0.9. So therefore, this is correct. Again, in interval notation, x such that x, okay, is less than or equal to 1.4. Oh, wait. So this is 1.4. Yeah. All right, so that is number 5. Let's move on to problem number 6. This time, we will use for multiplication, okay? For multiplication and division properties, actually, we simply use the MPI or the multiplication property of inequality. So we have 8x is greater than negative 72. Again, we will divide both sides of the inequality by 8. Okay, so 8 or x is greater than negative 9. Using our number line, so you have negative 10, negative 9, negative 8, and negative 7. So x is greater than negative 9, so let's encircle 9, negative 9, so we will exclude that. And the direction of inequality is moving to the right side. Then shade. Okay. Okay, so we have here the shaded part. So if we will let x, okay, x, say for instance, x is equal to negative 8. So the equation or inequality 8x is greater than negative 72. So substitute x is equal to negative 8. Is it greater than negative 72? So clearly, 8 times negative 8 is negative 64 is greater than negative 72. Okay. So therefore, our solution set is x such that x is greater than negative 9. So that is for number 6. Let's move on to item number 7. So we have here actually x over 3 is greater than or equal to 8.1. So what we're going to do is multiply both sides of inequality by 3. So I have 3 times x over 3 is greater than or equal to 3 times 8.1. So we have here x is greater than or equal to 24.3. Alright, so in our number line, let's have 24, then we have 25, 26, 27, and 28. So since we have here x is greater than or equal to 24.3, so 24.3 is somewhat here, right? So again, we shade that part, then the direction is moving to the right side. Okay, then shade. Okay, so this is the drop of the graph. Okay, and then since we are okay, we will check this. So we will let if x is equal to 27. So that is actually divisible by 3. So we have x over 3. Is it greater than or equal to 8.1? So if 27 is substituted, so 27 divided by 3 is 9 is greater than or equal to 8.1. So this is actually correct. So therefore, our solution set is x such that x is greater than or equal to 24.3. So that is for our item number 7. Next, let's move on to number 8. Again, so we have here number 8 is 3/4 x is less than or equal to 12. So what we're going to do is multiply both sides of the inequality by the reciprocal of 3/4, and that is 4 over 3. So we have 4/3 times 3/4 x, okay, is less than 4 over 3 times 12. Okay. So I have here x is less than, I can factor here 3. So we have x is less than 16. So for number 8, I'll put this one on the number line. But this time I'll choose, okay, 12, 13, 14, 15, 16, and 17. So x is less than 16. So I'll encircle 16, but exclude that. And I'll move to the left side. Okay? So clearly, this is the graph of the inequality. Now, to check whether our answer is correct, so if, say for instance, if we will let x is equal to 12. So again, we have 3/4 x is less than 12. So 3/4 of 12, is it less than 12? So factored out. So this will give us 3. So 3 times 3 is 9, is less than 12. So this is correct. So therefore, our answer in interval form is x such that x is less than 16. So that is for item number 8. Let's move on to item number 9. So we have 4x is greater than 12. So again, we will apply the multiplication property of inequality. So by dividing both sides of inequality by 4, so we have x is greater than 8. So, okay. So this is 32 divided by 4 is equal to 8. So again, on our number line, let's have here 7, 8, 9, and 10. Okay, so x is greater than 8. So again, I'll exclude 8 and I'll move to the right side. Don't forget to shade. Okay. Alright, so this is the graph of the graph. So we have x is greater than 8. Now, to check whether our answer is correct or not, so if x, let's choose a point, is equal to, say for instance, if x is equal to 10. So if I have 4x greater than 32, so I have here 4 times 10, is it greater than 32? So clearly, 40 is greater than 32. So our answer in interval notation as the solution set is x such that x is greater than 8. Alright? For the next number, so for multiplication and division involving negative coefficient, so let's consider number 10. So actually, we can use two steps here. So first, I'll remove positive 2 on both sides of the inequality. So subtract both sides of inequality by 2. So I have here negative 2x is greater than 8. Then, divide both sides by negative 2. Okay, take note that the moment you divide or multiply by negative, okay, in inequality, you will change the direction of, okay, inequality. If you will apply the MPI. So we have x this time. So since this is greater than, so we will change the direction. So the direction is actually, so we have now x is less than negative 4. So in our number line, so let's grab this one. We have negative 5, negative 4, negative 3. So x is less than negative 4. So shade, okay, let's exclude 4 and the direction is moving to the left side. Okay, so let's check our, okay, inequality. So say for instance for number 10, I'll choose if x is equal to negative 5. So x is equal to negative 5. So we have, okay, 2x plus 2. Is it greater than 10 if I'll substitute x is equal to negative 5? So we have 10 plus 2 is greater than 10. So we can say that 12 is greater than 10. So it is correct. So therefore, our solution set is x such that x is less than negative 4. Okay, so that is for item number 10. Next, number 11. So again, we have x over negative 5 plus 1 is less than or equal to negative 9. So what we're going to do is subtract first negative 1 to both sides of inequality. So what we have is actually x over negative 5 is less than or equal to, okay, negative 10. Then, of course, here I have negative 5, so I'll multiply both sides of the inequality by negative 5. So take note again, so if I already apply the MPI, I'll change the direction of my inequality. So I have here this time, x is greater than or equal to, negative 5 times negative, 10. So this is 50. Okay, so on the number line, let's use the interval by 10. So I have here 40, 50, 60, and 70. So x is greater than or equal to 50. So meaning to say, I'll include 50 to the shaded part. Okay, so we have now here our graph of the inequality. Now to check if our answer is correct, so we will let if x, say for instance, is equal to 60. Okay, so we have here x over negative 5 plus 1. Is it less than or equal to negative 9? So 60 over negative 5 plus 1, is it less than equal to 9? So this is negative 12 plus 1. Is it less than or equal to negative 9? So clearly, this is actually negative 11 is less than or equal to negative 9. So therefore, this is correct. So therefore, our solution set is x such that x is greater than or equal to 50. Okay, and for our last item is negative 2x minus 1 is less than or equal to 11. So again, so if I'll subtract both sides, or if I'll add both sides of the equation or inequality by 1, so I had negative 2x is less than or equal to 11 plus 1. So you have negative 2x is less than or equal to 12. Then divide both sides by negative 2. Again, reminder, so if we will apply the multiplication property of inequality, we will change the direction of the inequality. So a while ago, we have less than or equal to. So this time, we will have x is greater than or equal to negative 6. Okay, for our number line, so we have negative 7, negative 6, negative 5, negative 4, and negative 3. Since we will have, we will include negative 6, so shade that part, negative 6. Then we will move to the right side. Okay, so this is actually our graph of the inequality. Now to check whether our answer is correct or not, so let's choose a point greater than negative 6. So say for instance, if x is equal to negative 5. So we have here negative 2x minus 1 is less than or equal to 11. So we have negative 2 times negative 5. Okay. Minus 1, is it less than or equal to 11? So we have negative 2 times negative 5 is 10. Minus 1, is it less than or equal to 11? So clearly, 10 minus 1 is 9. So it's less than or equal to 11. So this is correct. So therefore, our solution set is x such that x is greater than or equal to negative 6. So that ends our lesson on solving linear equation or linear inequality in one variable. We apply addition property of inequality as well as the multiplication property of inequality. Again, this is Teacher One de Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos.